Hello everyone, and welcome to our video on finding all solutions of each equation, and we'll also list 6 specific solutions. So we have the work from a previous video right up above. The main idea in those problems are the same as these problems. What we want to do is isolate our trig functions. Okay, so notice in this problem we do have multiple sine functions. Well, you could combine them, just like if it's x and x, we know, well, let's do this right away. Let's subtract the 7 sine theta just so that I can combine the trig functions that are sine theta. Okay, so then I have 2 sine theta plus 5 is 3. Okay, so if I have multiple trig functions, sometimes I could just add them together or subtract them together, just like I did in this problem. Okay, and then now we should subtract the 5 because I want to get this sine of theta all by itself. So we'll minus the 5 on over, and we'll have 2 sine theta, 2 sine of theta equals -2. And again, I want the sine of theta all by itself. So we should divide by 2 to get sine of theta equaling -1. Now I'm going to use radians for this problem. It didn't say, but usually we assume do radians. If you want, you can use degrees. Now in the homework, it should tell you which one to go with. All right, so I'm going to use degrees, and this is saying you have a y-coordinate that's -1. Well, where sine of theta has a y-coordinate of -1 is in the bottom y-axis. And then we know that that angle is 3 pi over 2. And that's the only angle between 0 and 2 pi that gives us this correct value for our sine function. And then we know we want all solutions. It says all solutions. So that means we just need to add 2 pi k to this for all solutions. So this is all solutions. And I abbreviated solutions. I am going to box that because they often want that anyway. Okay, before I move on, let's check real quick. So how about I plug in the 3 pi over 2 into this original equation to see if it will work. So I have 9 sine of 3 pi over 2 plus 5 equals 7 sine of 3 pi over 2. I'm going to slant it above. Okay, so a little sloppy, sorry. And then plus 3. Well, sine of 3 pi over 2 is -1. So we'd have 9 times -1 plus 5 equals 7 times -1 plus 3. -9 plus 5 is -4. -7 plus 3 is also -4. Okay, good. So that means it does work. So again, we can always double check our answers. All right, now let's get to the 6 specific solutions that they're asking for in this problem. So the 6 specific solutions are any 6 that we want to choose where we just let k equal those integers. So we're going to let k equal 0, 1, 2, 3, 4, and 5. That's 6 answers right now once we plug k in. Okay, what's good about these is usually they have a nice pattern to them. So I would have theta equals 3 pi over 2 plus 2 pi times 0. Well, this is all 0 to the 2 pi times 0, so that means our final answer is just 3 pi over 2. And then we'll just put a comma, and we're just going to list them. Okay, so our next answer, 3 pi over 2 plus, let's plug in 1, 2 pi times 1. Well, instantly we would get a common denominator. So we would need to times the denominator and numerator by 2 of that other fraction. And then we can see, oh, it would be 4 adding to 3. So that should be 7 pi over 2, comma. And then let's do one more where we show the work. So we have 3 pi halves plus 2 pi times +2. And instantly we would need a denominator that has a 2 down there. And we'll times the 2 up top as well. Okay, so that gives us 2, 4, 8 plus 3 is 11. So we'd have 11 pi over 2. And then that's why I only showed the work on a couple, because we might start to see the pattern here. So notice our numerator is changing by 4 each time. So 3 to 7 to 11. are differences of 4. So that's what I'm going to do now to get the other 3 that I need. So they said list 6 specific. All right, so adding another 4 would be 15 pi, and then still over 2. Adding another 4 is 19 pi, still over 2. Adding another 4 is 23 pi over 2. There we go. So those are the specific solutions that they wanted, or that we showed them. So any 6 is good. It doesn't matter. So I just tried to find the fastest 6. Okay, so that's kind of rare when they ask for specific solutions in these scenarios. So that's why I did box the first one, but at least now we know how to do it in case we need it. All right, number 2 here. Let me block that one off. It's a tangent problem. We need to solve for tangent of t. So first thing then would be to subtract that square root of 3. So we have 3 tangent of t equals negative radical 3. And then we should divide by 3 so that our tangent function is completely by itself. So we'll have tangent of t equals negative square root of 3 over 3. All right, tangent, the way I think of tangent, so when we were doing inverse trig, is if it had a 1, it was right in the middle. So it's these 3 that I'm thinking about. It is negative though, so I'm putting lots of dots down. I'm gonna change my color in a second. Okay, so it is negative. I know tangent is negative in quadrant 2 and quadrant 4, but the way I think of tangent, when it had a 1, I think that was right in the middle. So this is tangent of pi quarters is 1, right in the middle. The first one, tangent of pi sixth, is square root of 3 over 3. And so I think of it as when I see 2 3's here, 3 plus 3 is 6, which is the denominator of that radian measure. Okay, and then the other one, tangent of pi thirds, is the square root of 3, and I see, oh, single 3, single 3. Okay, so that might help with our tangent scenarios. All right, anyway, what we need to do is make sure it's in the correct quadrant. So it is the one close to the x-axis, but in quadrant 2 and quadrant 4. Okay, so close to the x-axis in quadrant 2 is the 5 pi over 6, and close to the x-axis in quadrant 4 is 11 pi over 6. All right, now we can write our answer. We would say t is equal to 5 pi over 6 plus 2 pi k, comma, 11 pi over 6 plus 2 pi k. Now this should be a final answer. It should be good. However, sometimes they like to do stuff with tangent. I'm going to make a side note. And I don't really recommend it. I'm only doing this because they often force us to. Any tangent answer is always going to be pi apart. Okay, so from 5 pi 6 to 11 pi 6 is a length of pi. So once you have one tangent answer, you do always have the other if you add pi to it. Okay, so they're always a pi apart. So that means they could take the first answer, or any answer, and just add pi k to it. Okay, so that's what they might do in these problems to simplify. So I will cloud that. So this is a different way to write our t answer, as so. Okay, the last thing I want to do though, so again, the kind of the minor part, now it's just arithmetic. I need to find 6 specific solutions. Okay, so again, that's letting our k value equal. So now we're going to let k equal 0, 1, and 2. Notice I don't need to go that far with these because I have 2 current answers. So each time I plug in a k value, I'll get 2 separate answers. Okay, so let's plug in these values, and then maybe we can figure out a pattern afterwards as well. All right, so if I plug 0 in to the k, we have 5 pi over 6 plus 2 pi times 0, and then comma, 11 pi 6 plus 2 pi times 0. All right, so we have 5 pi 6 is what that simplifies into. I'm going to put our answer, so just to be safe, I'm going to go vertical with the answer, which I don't really like that much, but I think we could fit it. 11 pi 6. So 5 pi 6 and 11 pi 6 are currently 2 of our answers because 2 pi times 0 is 0. Now let's plug in 1. So when we plug in 1, we have 5 pi 6 plus 2 pi times 1, and 11 pi 6 plus 2 pi times 1. And then instantly we need a common denominator. All right, and so then we could say, well, 5 pi plus, this would be 12 pi, so that would be 17 pi. Okay, so let me put that answer right here, 17 pi over 6. And the other one is 12 pi plus another 11 pi would be 23 pi over 6. Okay, so like that. And I probably should have put them down below. Sorry, so I do need 2 more answers. Let me put the equals there as well. However, what I would be focusing on here is what's happening with this denominator. So let's set it up all the way. You might see the pattern, but let's just set it up all the way. So we have 5 pi 6 plus 2 pi. Now again, changing the k to 2. Instantly, we would need to get a common denominator. So 6 and 6 multiplies both, comma, 11 pi 6 plus 2 pi times 2 now over 6 times 6. Okay, and then so I'm just figuring out this denominator. 2 times 2 is 4 times 6 is 24. So it really is adding another 12 from the previous answer. All right, or now that we do have it set up, it would be, well, 24 plus 5 is 29. So I'm going to put those two answers right here, 29 pi over 6. Add one more. When we plug in 2 times 2 times 6 is 24, plus 11 is 35 pi over 6. There we go. So there is, so a little sloppy, sorry. But there are the 6 different answers that they were asking for. Okay, and that's it. There's our solving. Again, kind of the first box is probably more important, but whatever. All right, so they'll ask for different things sometimes. Okay, so thanks for watching. If you have any questions, please let me know.